For this question, we want to sketch the graph of the following function and identify all properties that apply. We're going to start with sketching the graph, and then we'll take a look at those properties. So to sketch the graph, I'm going to make a chart, a table of x's and y's. And I like to choose a standard set of x's, -2, -1, 0, 1, and 2, and substitute those into the function to get the y's. So if I substitute in a -2, that would be -2 squared is +4. -1 squared is +1. 0 squared is 1. 1 squared is 1. Let me back up because 0 squared is not 1. 0 squared is 0. 2 squared is 4. And this gives me a set of ordered pairs that I can plot to kind of sketch my graph out of. So we have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. I'll plot these points on my graph. 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. And what I see as a pattern is a U-shaped graph. This graph is called the parabola. And it looks like this. So there's a sketch of the graph. And now I want to go through these properties to see if they apply. The first property says this function is an odd function. An odd function has origin symmetry. So a graph or a function that has origin symmetry will have a mirror image going over the origin. So that means that your picture in the first quadrant would be a mirror image in the third quadrant. And if you have a picture in the fourth quadrant, it would be a mirror image in the second quadrant. And you can clearly see in our picture that our third quadrant right here, this is quadrant 3, is completely empty, and yet we have points in the first quadrant, so this function cannot be an odd function because we don't have a mirror image in these opposite quadrants. So we would not check that first statement. The next statement says the function is a linear function. A linear function happens when you have your variable to the first power. Our variable is squared, so this is not a linear function. Let's see the next statement. So the next statement says the function is increasing on the interval from -infinity to infinity. As I look at this graph, starting from left to right, my y values are decreasing along this section and increasing along this section. So my function is not increasing from -infinity to infinity. It's decreasing along this section on the left, which is from -infinity to 0, and it's increasing on the section on the right, which is from 0 to infinity. So this statement does not apply. The next statement says the function is an even function. An even function is a function that has y-axis symmetry. So when a graph has y-axis symmetry, you would have a mirror image folding along the y-axis, meaning that everything that you have on the right, you have a mirror or reflection on the left of the y-axis. The graph that we have here, if we draw a line along the y-axis, you can see that you have a mirror image on the left and right of that y-axis. So we would check this property to be true. The next property says the domain of f is negative infinity to infinity. I'm going to take my ruler and hold it vertically and think about when is the first time my ruler would hit the graph. Because of this line going on forever, it's going further and further left the higher and higher we see it. The domain would start at negative infinity, and because of this line it's going further and further right, the domain would stop at infinity. So my domain on this example would go from negative infinity to infinity, and so this property is true. I would keep that one. The next property says the range is negative infinity to infinity, so I'm going to hold my ruler horizontally and go from bottom to top. The first time I hit the graph wouldn't be until I get to a y value of 0. So for this function, the range starts at 0 and continues on to infinity. And so I would not select this property. The final one says none of these properties apply. Since I've selected 2 of them, I wouldn't check this one either. So the 2 properties I would select is that this function is an even function and the domain is from negative infinity to infinity. In this problem, we want to sketch the graph of the following function and identify all the properties that apply. So let's start by sketching the graph. In this function, we have f of x equals negative 4. And if I were to build a chart for this and choose my standard set of x's like negative 2, negative 1, 0, 1, and 2, I can see that this equation doesn't have an x variable in it, and this is what we call a constant function, meaning that the y is constant no matter what the x is. So we would get a y value of negative 4 no matter what x you choose. So my ordered pairs would be negative 2, negative 4, negative 1, negative 4, 0, negative 4, 1, negative 4, and 2, negative 4. The y is constant no matter what the x is. So these are the ordered pairs that I would get. And we can see that our graph is a horizontal line. So then let's take a look at each one of these properties. The first property says the function f is an even function. So an even function will have y-axis symmetry. So as I look at this y scale, I want to look at both the left and the right of the y scale to see if there's a mirror image. And there is a mirror image, so I would check this feature. The next property says the range of f is negative infinity to infinity. The range is the y values, and you can see that the only y value that we have is negative 4. So the range consists of a single point, and that's negative 4. And so our range is not negative infinity to infinity. The next property says the function f is a linear function. This is a linear function because the graph is a straight line. I would check linear function. The function is increasing on the interval from negative infinity to infinity. For this function, the y values are constant. The y values never increase, never decrease. They are constant for every value in the domain. So this function is not increasing, and I would not select that property. The next one says the domain of f is negative infinity to infinity, and you can see that every x value is covered. If you want, you can hold your ruler vertically and move that ruler from left to right, and you can see that your graph starts at negative infinity and continues all the way to positive infinity. So the domain of this is all real numbers, negative infinity to infinity. The next property says the function is an odd function. An odd function has origin symmetry. So origin symmetry would be reflecting, have a mirror image around the origin. So opposite quadrants would have a mirror image. So if I look at quadrant 1 versus quadrant 3, you can see quadrant 1 has no piece of the graph in it, and quadrant 3 has a piece of the graph, and so these are not mirror images of each other, and so this function is not an odd function. The last statement, none of these properties apply. Since I've selected some of them above, we would not check this box. Thank you for checking out my videos. Have a great day. For this question, we want to sketch the graph of this function and identify all the properties that will apply. Our function is f of x equals 1 over x, and I'm going to graph this by plotting points. My standard set of points include -2, -1. I usually choose 0, but 0 is an undefined value for this function. So instead of choosing 0, I'll choose a couple points that are close to 0. On one side, that would be -1/2, and the other side, +1/2. And then I'll continue with my standard points, which is 1 and 2. Now this function is given a name of reciprocal function because every number that you substitute in, you get out the reciprocal of that value. And you'll see that if I substitute -2 in, 1 over -2, that's -1/2, and -1/2 is the reciprocal of -2. I'll continue on with 1 over -1, and that's -1. -1 is the reciprocal of itself. 1 over -1/2. If I take my time simplifying this, I would write this as 1 divided by -1/2. And when we divide fractions, we multiply by the reciprocal, so that's 1 times -2 over 1. So we get -2. And -2 is the reciprocal of -1/2. You can do the same thing with 1/2. 1 over 1/2 is the same thing as 1 divided by 1/2. With fractions, we multiply by the reciprocal, and that's 1 times 2 over 1, and that's 2. So 2 is the reciprocal of 1/2. We have 1 over 1, which is 1, and 1 over 2. 1/2 is the reciprocal of 2. So I have a list of ordered pairs, which I'll plot on my picture. I have -2 and -1/2, -1, 1, -1/2 and -2, 1/2 and 2, 1, 1, and 2 and 1/2. I can connect these points. I'm going to connect this with keeping in mind that 0 is an undefined value, and that means I'm going to have a break in my line at that place. So I connect these 3 points together, connect these 3 points together, demonstrating a break at x equals 0. Some special features of this function is it has a vertical asymptote and a horizontal asymptote. They both occur at 0, and what that means is that our graph is getting closer and closer to x equals 0. The y approaches infinity and negative infinity. And then here my graph is approaching a y value of 0, getting closer and closer without ever reaching it. So this is the graph of the rational function, and I want to take a look at these properties that I have listed below. The first property is the function is an odd function. So an odd function has origin symmetry. And origin symmetry is when you have a mirror image over the origin over 0, 0. You're looking for a mirror image in opposite quadrants. So if we look at quadrant 1 as well as quadrant 3, we can see we have a mirror over that origin. If we look in quadrant 2 as well as quadrant 4, you can see that they're both empty, creating a mirror image in those quadrants. So we would select that this function is an odd function. The next question, or the next property, says the range of our function is negative infinity to infinity. And as I look at this, I'm going to hold my ruler horizontally going from bottom to top, and my range starts at negative infinity and continues on, but because of the horizontal asymptote that we discussed earlier, there's a break in the range at 0. So we never achieve a y value of 0, and so the actual range is negative infinity to 0, union with 0 to infinity, and so we would not select this property for this function. The next statement, the next property, says the function is a linear function. And for the function to be linear, we need the function to be in the form f of x equals mx plus b. So because our variable in this function is in the denominator, that makes it a rational function instead of a linear function. And so we would not select that property. The next property says the function f is an even function. For a function to be even, the graph needs to have y-axis symmetry. And y-axis symmetry is when you have a mirror image over the y-axis. So anything on the right of the graph needs to have a mirror image on the left. And you can see that quadrant 1 and quadrant 2 do not mirror each other, so we would not select the property that this is an even function. The next property says the function is increasing on the interval from negative infinity to infinity. As I trace this graph going from left to right, I can see that my y values are decreasing. And if I continue, my y values are still decreasing. So the function is not increasing over the interval negative infinity to infinity, so I would not select this property. The next property says the domain is from negative infinity to infinity. I'm going to hold my ruler vertically and notice that our domain would start at negative infinity, and continue until we get to this vertical asymptote of 0. 0 is not included in the domain, and so the domain is not negative infinity to infinity. The actual domain is negative infinity to 0, union with 0 to infinity. So we would not select this property. Then finally, none of the above properties apply. That statement is not true since I have selected a property above, so we would not select this property either. So the only property we would select is that the function is an odd function. For this question, we want to sketch the graph of the following function and identify all the properties that apply. Our function is f of x equals square root x. I'm going to graph this function using the plotting points method, and typically I'll choose a standard set of points for my x's to then find the y values. The standard set that I typically choose is -2, -1, 0, 1, and 2. But because our function is f of x equals square root x, I know that the square root is only defined for non-negative values of x. So instead of choosing -2 and -1, I'm going to start choosing at 0 and 1, and then I would usually choose 2, but I want some nice ordered pairs to graph, so instead of choosing a value of 2, I'm going to choose a value of 4, since the square root of 4 is 2, and then I'll choose a value of 9, since the square root of 9 is 3. So this makes it a little easier for me to plot points in my graph. The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. I have some ordered pairs. I have 0, 0, 1, 1, 4, 2, and 9, 3. These points naturally connect to each other. And I want you to notice at this point of 0, 0, my line comes to a stop. And that's because the square root function is undefined for all of these negative x values. So my graph comes to a stop at that point. Let's take a look at the properties. The first property says the function is an even function. And for you to have an even function, you need to have y-axis symmetry. So you need to have a mirror image over the y-axis. So whatever you have to the right of the y-axis, you also need to have to the left. If we take a look at our quadrant 1, comparing it to quadrant 2, you can see that we don't have a mirror image over the y-axis, so we would not select this property. Okay, the next property says the function is increasing on the interval from negative infinity to infinity. And this function is not defined on the interval from negative infinity to infinity. This function is only defined from 0 to infinity. So even though this function is increasing the whole time, it's only increasing from 0 to infinity. And so we would not select this property. As I mentioned just a moment ago, the function is defined from 0 to infinity. So this next property that says the domain is from negative infinity to infinity is also not true. So our actual domain for this function is from 0 to infinity. So we would not select this property. The next one says the function's an odd function, and that means that we have origin symmetry. And for you to have origin symmetry, you need opposite quadrants to have a mirror image. And so we would look in quadrant 1 and compare that to quadrant 3, and you can see that you don't have a mirror image. So we would not select this property. And the next one says the function is a linear function. This is not linear. Linear would be y equals mx plus b, and focusing on the x part, that would need to be to the first power. A square root of x is the same thing as x to the 1/2 power, so this is not a linear function. We would categorize this as a radical or root function. The next property says the range is from -infinity to infinity. If I take a look at my ruler and hold it horizontally and go from bottom to top, you can see that I have no y values along this bottom section, and the range doesn't start until you get to 0. So our range for this one would go from 0 to infinity, and we would not select this property. Since we've not selected any of the above properties, we would select this last one, that none of the properties apply. On this question, we're given f of x equals this piecewise function. You can see by the curly braces, we have two different equations. One equation is the absolute value of x, and the other equation is 1 over x. And then we're given some guidance here on when to use each one of these equations. In this one, it says if x is less than or equal to 0, we're to use the absolute value equation. If x is greater than 0, we're going to use this reciprocal function 1 over x. We're given a few parts here to work out. We want to find part A, which is f of -2. In f of -2, we're given that x is -2. And since -2 is less than or equal to 0, I'm going to use the absolute value equation to work this example out. The absolute value of -2 is +2. So f of -2 is 2. In part B, we have f of -5, x is -5, and since -5 is less than or equal to 0, I'll use the absolute value equation to evaluate this function. That's absolute value of -5, which is +5. So f of -5 is 5. Then finally, we have part C, which is to find f of 3. X is equal to 3. And since 3 is greater than 0, we'll use the reciprocal function to evaluate. 1 over 3, and that's 1/3. f of 3 is 1/3. Thank you for checking out my videos. Have a great day.